Okay, so here we go. When I look at secant plus tangent squared, let me write that. Secant plus tangent, I should say quantity squared, like that. When I look at that, and I see that secant and that tangent, and I look at the right side, so this would be like on the, let's say the multiple choice exam we're going to take in a couple weeks on this material. If I saw the right side and it had sines and cosines and stuff, you know what I would think to do? I would think, oh, okay, I probably need to write that secant and that tangent in terms of sines and cosines, right? So what is secant? 1 over cosine. What is tangent? Sine over cosine. Good there. So far, so good. And that's exactly what they did. Next, I've got to actually square that, FOIL that. Well, let me do it this way. What I could do is I could say, look, that's 1 plus sine over cosine squared. Everybody good to there? I combined those two, right? That's just common denominator, isn't it? When two fractions have the same denominator, you can put them together to make it one fraction. Everybody good to there on that? So I just combined them like that. So it's 1 plus sine over cosine. Now I can square the top and square the bottom. So that means 1 plus sine, 1 plus sine. The bottom is cosine, cosine. I'm just making 2 of them on the top, 2 of them on the bottom. That's what that 2 means when it's on the entire fraction. Are we okay to there? Is that making sense? And now, FOIL out that top. So what do you get? 1 plus sine, and then boom and boom, plus sine squared. On the bottom is just cosine squared, right? 2 cosines. Are we okay? Am I racing ahead of you there? Is that making sense? And then, what is sine plus sine? 2 sine, huh? So 1 plus 2 sine plus sine squared over cosine squared. Now, that's kind of weird. Like, what do we do from here? Keep in mind the goal. How can I get to here? Look at the bottom. The bottom has sine stuff. I have cosine stuff. See how I'm thinking? I'm always looking at the target. I'm always looking at the target thinking, how do I get there? So you can't just forget about the target. Right? You always got to be looking, saying, okay, look, the bottom, the target is 1 minus sine. It's 1 minus sine, and I've currently got a cosine squared. How can I turn that cosine squared into something in terms of sine? Since I've got to get sines on the bottom, how might you do that? The 1 plus the Pythagorean identity, the 1 plus sine. Yeah, remember, so that cosine squared, what can I replace it with? Good. 1 minus sine squared. Cosine squared is 1 minus sine squared, huh? Remember that? We do that. That's like in every problem, isn't it? Getting the hang of that thing? It's in virtually every problem. You can always replace sine squared or cosine squared by 1 minus the other one squared. That's only for squares, though, not for first powers. Does everybody see what I'm saying? You can't replace 1 minus regular sine with cosine. No. Well, 1 minus sine squared is cosine squared. Yeah, that's true. Everybody good with that? So it's 1 minus any of them squared is the same as the other one squared. It's a squared formula. Okay. So why do I even think? Because what's hard is there's a million formulas. How do you know which one to do when? Well, it's all about the target. I'm looking at the target, saying, look, that it's sines, and I've got cosines. Do I have a formula to change? Oh yeah, I better change it. I better change it. That's what made me think that. Okay. Now next step. What in the world could we do with our next step? Well, what can you? 1 minus sine squared. You can factor. Remember the factoring thing? That's 1 minus sine, 1 plus sine. On the bottom. Everybody see how this is this? Remember that's the factoring we looked at earlier, the algebra factoring. Is that good? And then the top, what about the top? We can actually go, really we should have left it back here. Let's go back to this version. Whoops, forgot the 1 there. 1 plus the sine twice. 1 plus the sine, 1 plus the sine. I'm kind of going back to that version. Why? Because of that now. Do you see that? And there's our answer. There's the final goal that we had in mind. That. We're left with just 1 plus sine over 1 minus sine, which is what we want. There it is. Everybody see those steps? Questions on that? I know this is kind of a challenging section. We'll get back to more regular stuff after this section, instead of just moving formulas around. No questions? Is that okay? Everybody see those steps? So I took the original. So I wrote secant and tangent as 1 over cosine and sine over cosine. And then I FOILed out the top. And I replaced the bottom, cosine squared with 1 minus sine squared, and factored it and canceled. All right, so if you just write it yourself again, if you just between now, when you go over the exam, when you go over the homework, if you just write it yourself, right? There's something, all the education studies show that as you write things, it prints it. It's actually, don't just look at it, write it on a paper. Write these steps out, and your brain records better and better. They're doing all kinds of studies now on the difference between typing and writing and how people remember. They've done all these university studies. Dean was just sending us results. I'd heard about them before as well. That you actually remember things better that you write than when you type. There's something about the writing mechanism that sinks it well into your brain. They do these tests where they have one group of students type information, others write, and then they test them afterwards, and they're repeatedly finding that things we write, we remember a lot better. So write these out. When you redo these, write what I just did a couple times, and you'll get it.